let's start by looking at how we can construct a simple network and what we can do with that. So this is very basic stuff. So the first thing we want to do always, of course, is Python, is we want to figure out what are the imports that we need to use for this. So we want to import network_x, which you should probably get easily given that you've installed Anaconda's Python. You want to make sure we're going to draw the network, so you want to make sure that you're using matplotlib inline so that we can see the network on in the notebook. We want to import NumPy because we might need it, and we want to import pyplot because we might need it. Okay, these are the basic imports, and this should be pretty much it for the networks, but we will see down the road. So we want to make a simple network. A network is a set of nodes and a set of edges. So the first question when we want to create a network is we want to ask ourselves, what are the nodes and what are the edges? So let's say we start by creating a bunch of nodes that are these in this list: 1, 2, 3, 4, 5, 6, 7, 8. So notice that these are all immutable integers. 1 is a node, 2 is a node, 3 is a node. We can give anything we want as long as it's immutable. So we set up a simple network. We set up a network by using this function nx.graph. Nx, if you recall, is our network_x module, the alias for our network_x module. So we set up our network by saying nx.graph. So what this does is it creates a network object, a graph object for our network. And what we want to do now is we have the network. It's empty. We haven't added any nodes or edges to it. So what we want to do is we want to add these nodes and add the edges. So our nodes are these things here, and we can just add them using the function add nodes from and give it a list or some collection of nodes. So that's going to add the nodes 1, 2, 3, 4, 5, 6, 7, 8 into the graph. Then we want to add the edges. Edges are the linkage between two pairs of nodes, right? Between a pair of nodes. So this tells us that 1 and 2 is linked, 2 and 3 is linked, 1 and 3 are linked, 4 and 5 is linked. So clearly 1 and 4 don't have an edge between them. 1 and 2 have an edge, 2 and 3 have an edge, 1 and 3 have an edge, but 1 and 4 doesn't have, because we don't have a 1 and 4 here anywhere. So we add that using the function add edges from, and then we can take a look at our network by just drawing it. So let's draw that, and we don't get this because I have not imported it. Okay, we can ignore these warnings. Anything that comes in pink is a warning, and this is telling us that some of these functions that actually network_x is using, I believe, are deprecated and may not be valid in later versions of pyplot. This is one thing you have to watch out for in Python. When you have something that's working, you probably don't want to change the libraries or upgrade the libraries for that application. So one of the things that you can do in Python is run virtual machines, and we don't have time in this class to look at that, but you might want to look up that stuff here, virtual environments, I'm sorry, and look that up online and see how you can set up a virtual environment. What the virtual environment will do is it'll take all your imports and sort of seal them in that environment, and then if you upgrade a library in some other environment, it's not going to upgrade it in this environment, so that you know your package will keep running. So it's not a bad idea. But anyway, this is our network now. So we get this network here, and it shows us our nodes and our edges. Of course, we don't know what the nodes are. So what we can do is we can add a few labels to the nodes. So I'm just going to walk through this because we will be using this a lot down the road. You will be using it a lot. So let's say we start with our simple network, and we're going to give it a layout. There are many possibilities for layouts in Python, in the network_x. So for example, I could say here nx dot random layout, I think, right? Random layout. That would be another layout, and there are quite a few of them. You can look up all the various layouts on network_x, but Spring layout is just a very simple sort of way of looking at a network. So we'll use that. So we have nx.spring layout, and we tell it we want to take our simple network, the one we defined earlier with the edges and nodes, and keep that in this network. Keep that as the layout of our network. All right. Note that the layout of the network has nothing to do with the graph itself. It's more for the visualization than anything else. Then we draw the nodes. Okay, so we draw the nodes, and we give it using the function draw network_x nodes. Very straightforward. We tell it the network we want to draw it for. We want to give it the layout that we want to use. Right. That's our POS here, which is the layout that we're using for this. We give it the color of the nodes, and R is for red, B is for blue, Y is for yellow, G is for green, that kind of stuff. We give it a node size, and this again you can play out around with a little bit to see. So given 500, obviously if you give a higher number, you're going to get a larger node, the visual of the node, and a smaller number will give a smaller node. And the alpha is the matplotlib thing that we're looking for, which what it does is it tells you how dense the color of the node is going to be. A lower alpha will make it more transparent, and a higher alpha will make it more opaque. So that draws our nodes. Once we do this, our nodes will get drawn. Then we want to draw the edges. So for edges, again, NetworkX has a simple function, add NetworkX edges, and we tell it the network, the layout, the list of edges, and the list of edges is what we gave up ahead on the top. The width of the edge, so this tells you how thick the line is. Edges are represented as lines, so this tells you how thick the line is. That, of course, alpha is the color density, how opaque or transparent it is, and we give a color to the edge, B, which is blue. So we're going to get a network with red nodes and blue edges, which is different from here where we had, well, some odd looking color, orange, reddish, pinkish thing as the nodes, and black as the edges. Now we want to give the nodes names. So what I'm going to do here is I'm going to create here a list of names of nodes, or rather a dictionary of node names, and then for each node in my list of nodes, so 1, 2, 3, 4, 5, 6, the list of nodes we had, I'm going to add to that the node number, so it's an integer, and a string version of that node. Okay, so because it'll look nicer with better with strings anyway. So then what we want to do is, and we need to pass it as a string. So I think we need to pass it as a string. So that's why we have a string node here. And then we draw the labels. So the labels are what's going to show up as 1, 2, 3, 4, 5, 6, 7 in the thing. We give it our network. We give it the layout. We give it the list of, or in this case, a dictionary of node names, and we give it the font size. So this is really a mapping from a node number to a node name. So that's what we have over there. We turn off the axes because we don't need an axis for a network. There's no X and Y, and we show it. So let's see how that looks like. And we get a nice looking graph like this. All right. Note that this is going to be different every time we run it because it's really just laying it out as we like here. So this tells us now we have our nodes numbered and edges nicely colored in blue. And we can play around with this a little bit. We will do that down the road to add more information to our graph. But the basic graph is very straightforward. What you want to do is you want to decide what the format of your node is, the color, the transparency, etc. You want to decide what the format of the edges are, the color, the transparency, etc. You want to decide what data you want to show up in the node, because remember, the node can actually contain lots of data. For example, if there are people, you might have the social security number, the name, the address, phone number, all that kind of stuff, and you don't want to pack all that into this. You might want to just pack in the first name of the person or the last name of the person. So you can extract that and use that over here instead of using the entire node contents. Right? That's the idea there. And then you use the NetworkX labels to actually render the labels on the graph. So that becomes our simple graph over here.